session today is on disk-triggered ignition. I think many of you are aware that that's remains a substantial part of Ultronic's business. And we have one of our senior folks here, Tom Smith. Tom's many of you know Tom is a senior service person with Ultronic. He's been with us many years and is well versed in this topic. So Tom, I'll pass this over to you here, but to the rest of you that have joined, thanks for coming, and you're in good hands with Mr. Smith.
Okay, well, good afternoon, everybody. And today we're going to talk about disk-triggered ignition systems. Just to backtrack a little bit, we have a number of different products that we're able to move into from the solid state mechanical ignitions, and Ultronic 1, 2, 3, and 5s. Ultronic 1s are small engines, 1 to 6 cylinder inline, 1 to 3 cylinder horizontals. The Ultronic 2, there are not any disk triggered systems that are going to replace any of the Ultronic 2s, 2 CPUs, or any of the large engine, integral type engine applications. But Ultronic 3s and Ultronic 5s, all the way up through 16 cylinders, we have NGI 1000s on the top end that do up to 16 cylinders. So there's a large spread of applications between CD1 at the very beginning all the way up through the NGI 1000 that are all disk triggered, or holes in a flywheel, drilled holes, something that are events on a disk or on a flywheel that can trigger the ignition. So when you're ready to move into these newer systems, obviously you have to have DC power. You know, all the Ultronic 1s, 2s, 3s, 5s, those are all self-generating solid state mechanical ignitions. So now when you move into the CD1s through the NGIs, you have to have DC power. So the evolution in families, the Ultronic 1, typical, up through maybe a 6-cylinder application. Ultronic 1 has only up to 3 outputs, but you can go into the CD1, DC powered, and very simple system, lowest cost, simplest. Ultronic 2s, 2 CPUs, CPU 2000, CPU XL, nothing in the disk triggered family to go into in that family. Ultronic 3 and 3NG, some of those moved into the CPU 90s, went to the 95s, 95 EVSs, but the other family that you can move into, and it depended on whether you were able to conveniently mount a disk or drill holes in the flywheel, and that was to go into like a DISN. We had the CECs on the Waukesha's all the way up through the 7042s, 9390s, and we have CD1s, which then branched down into the CD200. DISNs were more like the CD200D. And then beyond that, we have the NGI 1000, which is the latest family with the most features and most versatility. And then we have the Ultronic 5NG family that goes into the CD1 and then into the CD200 typically. So just want to point out that the downloads page on our website has all of the literature on all these systems. And for example, like this one, the DISN 800 NGI 1000, the DISN 800, just like all the other ones, are going to have a brochure, an application, installation, then service. And then if you were to look at like the NGI, it's a brochure, installation, and right now it doesn't show here, but there's also service. So all the literature is available on our website. So the very simplest system, we'll start at the beginning, CD1 ignition, 1 to 8 cylinder engines, universal, low cost, accurate timing, as accurate as the holes are in the disk, extended spark plug life versus inductive systems, if you're replacing a magneto of some type, no moving parts, 12 to 24 volt DC powered, CD ignition like all the Ultronic systems, and that's a high energy spark, and it's got built-in diagnostics. It's got some LEDs, tells you if the magnetic pickup is operating, and also has one for the output circuit operation. So you can apply this to either single firing or double firing exhaust stroke firing modes. 4 units are offered with 3, 4, 6, or 8 outputs. Many of the smaller systems like Ultronic 5s, you might use a 3 output unit on a 6-cylinder engine, and that would be a double firing. So you can do the same thing with the CD1, drilling holes in the flywheel. And this just shows a simple installation, 4-cylinder application, exhaust stroke firing. And you have on the disc here, you have a 2+1 disc. First hole that goes by, and that's your lineup angle. You have the A firing, and then you have the B firing, and then a short distance later, this is 0, 180, and then 210 degrees. You're going to have an index hole, and that is going to tell it to restart the count. And then as it passes by the next one, you're going to fire A and so forth. So this one, you're only using 2 leads out of there, A and B. A goes to the first coil. The minus of that coil goes to the plus of the second coil. Both those cylinders are at top dead center. One's on power stroke, one's on exhaust stroke. So that's a typical exhaust stroke firing application. CD1 has 3 cables coming out of it, one for power, one for the primary connections to the coils, and the other one going to the magnetic pickup. The disc or flywheel drilling pattern, many of these are in a metallic disc with a magnetic pickup. Sometimes they're in the flywheel. For the very easiest, lowest cost application, typically you'll drill holes in the flywheel. And that you can mount the magnetic pickup through the bell housing or on a bracket, depending on the engine type. And through that magnetic pickup hole, you would drill these holes in the patterns that you see in the installation instructions. And that's a very simple system. And the timing never moves once you drill the holes. So drilling the flywheel, you put the number 1 cylinder in the most advanced timing position. Mark the point on the flywheel that is directly opposite the pickup. And then you drill a 3/8 hole at that point. And we have drawings to show you how to do that. The remaining holes are spaced as shown. It's either 0, 180, 210. 3 or 6 cylinder, you have 3 holes plus an index hole, 0, 120, 240. And then the 8 cylinder are 4 evenly spaced at 0, 90, 180, 270, and then the index holes. So obviously when you lay this out, the unit's going to fire wherever those holes are. So you want to be accurate in your layout and make sure that you've properly marked them and drilled them, and then that's where you're going to fire. There's a timing switch under a white plastic cap at an end of the box. The range it varies depending on whether it's the 4 output, the 3 or 6 cylinder engine, or the 8 cylinder engine. The number of degrees per switch interval and the total number of degrees will vary for the application. Typical installation, and when we say drill the first hole at the most advanced desired location, from there you can retard the timing, but those are only in the increments on the switches. So if you intend or perceive somebody to want to advance the timing, perhaps you set it or drill the holes 5, 6 degrees ahead of where it typically runs, and then you use the switch positions to retard back to where you actually need to run. So at full operating speed, you use a timing light, use the switch positions, and set your timing. The next step up is the CD200. Again, it's pretty much universal. CD ignition 6, 8, and 12 outputs. So we don't stop at 8, we move into the 12. But what this can give you now, and it's got a terminal program so that you can program it, and it gives you the ability to program timing versus RPM. It also gives you an analog signal input, which could be a potentiometer or a 4 to 20 milliamp signal. It's got selectable spark energy, so you can crank it up if you've got a lean burn engine, or drop it back if it's a conventional engine that doesn't need a lot of spark energy. It's got an adjustable overspeed trip and the ability to give or program individual cylinder timing settings. And we've got if you look at the picture on the right, we've got one with the leads coming out, the harnesses coming out. That's an unshielded version. And then we have one with 2 MS connectors, and that's good for a class 1 group D division, group C and D div 2 application, shielded. So the diagnostics for the system, you have PC-based diagnostics where you hook up a computer and use the terminal program. We also have flashing LEDs on the unit. It's got Modbus RTU communications and control, an 8-position timing switch to initially set the timing, the terminal program that you download from our website. Configure it for any small engine. It's a single pickup design. And again, this could be firing on the exhaust stroke firing principle, or it could be only on the compression stroke if you mount the disc at cam speed. We have a few application photos here, and we've got the ignition coils you can see up here, the CD200 mounted on the side of the engine here. This one, CAT 3306, and you can see the negative ground coils mounted up here. These are the more conventional round type coils. The CD200 units mounted here. We've got a J-box, and up here we've got a pickup that is going to a disc and a plate. This is manufactured by one of our distributors, and they have that available for sale as a kit. And this is the disc that they've made for inside there. So they aren't drilled holes. They're actually machined holes in a metal disc. And this is the magnetic pickup. And this is a shielded type system, as you see here. This one's on a MAN 2866. You see the ignition module right here. Coils, we've got a rail, and ignition module mounted over here. This is on a Hino, and this one's got the coils mounted here. This one has a disc mounted in the old magneto drive. This one happened to be at a slower speed so that you can trigger right off of that and give it 6 individual pulses. And now we're into the CD200D. So the CD200D doesn't look like the CD200 on the bottom right here. It goes into an enclosure that looks much like the DISN. And when you look at that, you're going to see that in the DISN enclosure, we have 8, 12, and 16 output models. They all have 19-pin primary connectors, which are similar to all the CPU 95s and their predecessors. It'll work with either a Hall effect or a magnetic pickup input, so it's, again, more versatile. It's got a terminal program so that you can program all of these variations. And since it's not potted like the other products, it's repairable. It has replaceable circuit boards. It's a great retrofit for EISN ignitions. Same form for mounting, same footprint, same power draw and voltage requirements. Can reuse the Hall effect pickup and magnetic disc if it's desired. Added features over the DISN. It's got advanced diagnostics, including LED on the ignition, as well as through a terminal program on the software. The EISN did not have a terminal program. It's got primary and secondary diagnostics, like a CPU 95 might, as well as low power supply voltage and shutdown indications, among others. Got individual cylinder timing adjustments and timing versus RPM map. And it's got completely customizable features and programming available through the terminal program software. And you can use either a magnetic pickup or a Hall effect pickup. And it's got selectable spark energy levels. This is the magnetic pickup harness. And even though it's MS connector on this side goes to the lower cost magnetic pickups with a plastic type connector, an automotive style connector. And when you get into the shielded, it's got a similar MS connector on this end, but this would go into a J box, and then the mating harness that goes to the pickup, it would also be shielded. It would go into that same J box and be terminated between these two harnesses. Hall effect input for unshielded. This end has the MS connector for the Hall effect. This end, and this is a little bit different because of the MS connector. We don't make any magnetic or Hall effect pickups with the automotive grade plastic connector. So this will always be an MS connector for the Hall effects. And this is the unshielded harness. The shielded harness going to the unit MS connector, this goes into a J box, and then the mating harness goes into the J box and terminates together. The CD200D terminal program looks like many of our other programs, whether it's CPU 2000, CPU 95, a few different variations and selections. The disk type setting, you can, as it's shipped, it's set for a 0+1, and there's no test disk selected. And when you put it on, it will automatically read the disk, whether it's 4, 6, or 8 inputs from the disk, and it'll automatically sync into that and give you the appropriate number of outputs. But if there would ever be a problem with the pickups or the Hall effects or any part of that circuit, it wouldn't know that there's something wrong. So many people will choose to put in the exact 8+1, 4+1, whatever, and then click on the test disk. And then every revolution, it's going to test for the correct number of pulses, including the index pulse, and then give you an error code if that is not correct. We've got the lineup angle setting. This one's set up at 40 before. Insertion retard, purge delay, number of cycles, so that after it starts rotating and sees pulses coming in from the disk, it's going to wait that many pulses to actually start firing. You've got an overspeed setting, a run speed setting, low voltage setting, and we've got diagnostics and slave firing, energy bit settings, slave firing. That's something that you use with the application list. And some of these engines, when you get into something more than 6 cylinders, some of the 8s, 10s, 12s, 16s, they don't have an even firing pattern. So they might fire, 60-30 or 30-60 or something like that. And all the discs have even placed holes drilled in them, or the disc has evenly spaced holes. And in a case like that, we create slave angles so that we can fire at an angle in between the two holes. So again, through the application list, that's explained, and then you can select the proper selections for slave angles. So the rest of the terminal program gives you, these are read, this fills in as you're operating the engine speed, your spark timing, switch position, loop input, observed disk, insertion retards, switch retard, loop retard, RPM retard, total retard, summation of these right here. Got 2 + 6 equaling 8. Number of cycles, purge counter for the number of cycles, your supply voltage, and if you'd have the G lead ground, it would tell you here, tell you if you have a disk error, tell you if you're running, cranking, and so forth with all the LEDs that are on the terminal program here. In many cases, unless you really get into a problem on a smaller system like the CD200, 200D, most people won't want to connect a computer until they've looked at the LEDs on the side and they've somewhat come to a conclusion that they need to look further. The other thing you see here, there's individual cylinder calibration. So if you would want a certain cylinder that was detonating to be retarded a few more degrees, you can put that in here. The switch calibration, this gives you 7 degrees of retard on switch position 0 all the way through 7, which is full advance. The loop, again, this one's got 16 degrees of retard at 20 milliamps and starts out at about 4 milliamps with 0 degrees of retard. And then you have this is where you put in your timing versus RPM calibration. And this basic page is the same for the NGI 1000, CD200, CD200D, all the variations that have a terminal program in this class. The EISN, they've been around for many, many years. There's a few slight differences between those systems and the CD1, CD200s. These were initially released where these always had a Hall effect input as the trigger, and the disc had magnets embedded in the aluminum disc. So the triggering is slightly different, but very similar. It's the same 4+1, 6+1, and so forth. Most of these discs are offered for sale. Magnets embedded in the periphery of the disc. And we offer them in 5 and 7.45 inch diameters in all the different variations, 4+1 all the way through 12+1 with the magnets. We offer DISN 801M, and that was designed to be a more economical version, and it used a magnetic pickup instead of a Hall effect pickup, and used a different type of trigger disc. It was actually a disc with aluminum with metal inserts, which would trigger the magnetic pickup. And that's somewhat fallen by the wayside since the NGI 1000 does everything this will do, cost effective in comparison to these. And also the NGI 1000 will do any type of a pickup, Hall effect, magnetic, powered, inductive, all the different types. But the EISN, there were originally a number of different variations, the 400, 600, 700 variation. Now there's an 800C, an 801C, and the 801M, which this one's moving towards the NGI 1000. 800C and 801C, these are just two different groupings of switch settings for the different firing angles. On each of the units, there is a chart right here, and this switch position on the side will give you different firing angles for different discs. So this is not an auto detect type system like the CD200. You have to actually put a 4+1 disc on it and select a 4+1 firing pattern on the side by using the selector switch. So we've got up to 16 outputs, single Hall effect input, 2 PCBs, a power and a logic, aluminum housing, the selectable applications, that's the chart on the face of it, and the selector switch, and those are all programmed into an EEPROM. One of these, the 800C versus the 801C, the 801 has more of the European engines. If you look at the application list, it'll tell you the different firing patterns that are available on each of them. We upgraded the enclosure from a stamped steel to the cast aluminum in 1996. Gave us a lot more moisture resistance and improved the power circuitry at that time also. The timing control on the DISN, we had the manual timing switch on the end, and that with click positions that would retard the timing back. The pickup and disc alignment. We had a separate timing control connector, the small connector on the side over here. That gives you the ability to give it a 4 to 20 input or a potentiometer, or to do one-step timing control. The diagnostics on the front, you've got 3 LEDs, one that tells you when your power's on. The other one's the application. That means that the switch you've selected on the side and the disc that it sees rotating is working in alignment. There's a pickup input LED that's going to tell you that your pickup is pulsing. And then you've also got a fault for the primary or the alarm output. And we'll talk a little bit about those later. The layout, we've got the switches on the side, 3 amps maximum, 24 volt DC. We've got the power, the pickup, and the application LEDs on the front. You can see the application switch on the side and then the timing switch. This is the timing control connector for your 4 to 20, and it's got a cap over that. The switch applications, for example, if you're on position A, 6 outputs, it's for a 6+1 disc, gives you 60-degree even output, and it fires on A, B, C, D, E, and F. On the switch position B, number of outputs, whether it's a 4, 8, or 16, it uses an 8+1 disc, and then it's going to give you either a 90, 45, or 22.5-degree even pattern. C and so forth down here. So these charts show you a little bit more about what the application is and number of outputs and the disc to be used with it. So now we're into the NGI 1000, and one of the NGI 1000s will do everything and more that the previous systems will. Obviously, if it's required to be cost effective and it's a small engine that's lower cost, you just want to do the most you can with the least amount of money, you would use the CD1, but as the systems go up in price, so do the features. NGI 1000 literature, just want to point out to you that there's a 1000 and a 1000 RC, and there's installation for both of these, and they are different, so you want to pay attention to that. So these two systems, RC stands for remote control. Generation 4 advanced digital ignition for small and medium-sized industrial engines, delivers expansion of remote control functionality through firmware, terminal program, and Modbus data mapping. And this system, the 1000 RC firmware the following parameters can be continuously written without impact to EEPROM right cycle durability. And what that means is that we have the ability in like the 95 and the standard NGI 1000, the ability to change many of the parameters, but they have limited write erase cycles. And if you look here on the right, this is out of the installation instructions. It only gives you 100,000 of these write erase cycles. And if that is something where this comes into play is a lot of the European engine manufacturers are working with this system, and they want to use their own engine management system, and they want to write timing values, energy values, spark current duration, um, cylinder offsets. They want to write to them, and sometimes they want to write to them hundreds of times per minute. So when in a case like that, you could easily exceed this 100,000 write cycles in not very long. So the RC is made so that there's uh, a number of values, these four values: spark duration, current, ignition timing, cylinder offsets, where you can continuously write to them without impact to the EEPROM write cycle durability. So you could do it 10 times a second for the next 10 years and it won't affect it. Most of the like a CPU 95 or many of the engines without an engine management system, you basically set the timing, and you may utilize a timing versus RPM map or use a 4 to 20 to globally change the timing. But again, those are different ways to make the engine behave as you need it without individually changing timing, without changing the energy levels constantly. So again, the RC is geared towards the applications where you have an engine management system that wants to change those parameters continuously while you're running the engine, and sometimes many times even per second. So there's four models: an 8-cylinder and 16-cylinder model, and each of them are available in the RC variation. This is the picture of the ignition module 791-973-16. We've got 3 LEDs on there: the HV, the diagnostic, and then the 24-volt LED. So it gives you a quick, easy look at what's going on just with the LEDs. So this is the 4th generation event trigger system for small and medium-sized engines, 1 to 16 cylinders for natural gas and biogas applications. Biogas, where the BTU content can vary depending on how it's generated and whether it's digester gas or where it's coming from. It could really vary, and at some point you may even have to substitute or blend propane or blend in natural gas to get the BTU content up to where the engine will carry the load. So with all those systems, in some cases you have to give it more spark energy. And this is the state of the art spark energy control, like the CPU 95 EVS. Um, and it's a current versus time energy control, and you select those values. And you can select the current between 50 and 200 milliamps and durations up to 1100 microseconds. So that's quite a bit hotter than any of our older systems that were strictly capacitive just discharge. These have the ability also to back off to where you're just doing a CD type spark. So it can replace a DISN and behave exactly like that, or you can ramp it up and program it to give you much hotter ignition, and maybe only when you're running the lowest BTU quality fuel. So the system is configured, not programmed. We've got the terminal program. It's a Windows-based terminal program that's downloaded from our website. We've got onboard LED-based diagnostics. It's got Modbus RTU communications. And again, both of them, you can talk to them with Modbus RTU, but it's the um, RC version that you can continually write those four values or four registers to make it perform as you wish. And again, this is a group C and D class 1 div 2. So it's got backwards compatibility with CD200 systems and alternative systems. The power requirement, especially when you get into the higher energy levels, this can draw up to 7.5 amps. So you're going to have a fairly hefty power supply. Most of the DISNs ran on about 1 amp of current, some of them maybe 2 amps, depending on the RPM and your other selections. But um, again, this is going to draw quite a bit more power. Terminal programs, structure and feel is similar to the other Ultronic products. And with this, you can use a mag pickup, Hall effect, and powered inductive type pickups. It's got a durable enclosure and military style connector, which ensures reliability in difficult and demanding environments. And it's got the patented control technology uh, for the spark duration and voltage. Basic system looks much like the smaller systems, except that the harnesses go out to instead of 3, there's just the 2 with primary harness and then the one for the control. And that's got your pickup and your DC power. Mounting footprint's the same as all the other systems, so the backwards compatibility, if you want to replace one with the other, it's all easy to do with the same mounting footprint. Single fire with magnetic pickup. You see the magnetic pickup here, the disc um, harness. There's 2 different harnesses for magnetic pickup versus Hall effect. You got to order the correct one. Wiring is much like all the other systems we've ever offered. You've still got a shutdown lead in the system. When you have a powered pickup, you've got 3 wires to go out to, and again, that's a different harness, and you can use either Hall effect pickup or the inductive powered pickup. Blink codes, 3 LEDs on the side for your diagnostics. You know, if you look at the chart, on steady or it's ready, new power up or last startup temp aborted. If it's one blink on, one blink, and then back on, it fired the last time rotating. If it's on, then 2 blinks, and then on again, it's shut down by grounding the G lead. 3 blinks is by remote serial request when it's running, 4 blinks by overspeed. And so blink codes are pretty typical. We used them on the anything from the CD1 all the way up through uh, the EISN products. The software package, we looked at the other one and many of these values were almost the same. The thing that you'll see that's different, and this is not for the RC version, this is the current and time. So you can select those 2, and in the manual, it gives you a chart with those available voltages that you can select. There's also 2 selections for powered pickup, and when it's powered, it may be triggering on the falling edge or rising edge. If it's rising edge, you don't select this, but if it's triggering on the falling edge, and we've had some pickups that are of that type to integrate with, so you can select that also. It's also got the ability to allow you to put in a 4 to 20, and also those are the two terminals, pin F and G, and pin E and F give you the ability to use a 1,000 ohm potentiometer, and that's in this chart right here. Then we also have the ability to program in the timing versus RPM. So spark current and duration. Uh, it's important to tailor the spark current and duration to the engine demands. Obviously, if you selected the highest levels, you'd wear out your spark plugs very quickly. And if it's a stoichiometric engine running on good gas and it's not overloaded, you obviously ran on an Ultronic 5 or 3 or something else very simply with, inadequately. So you don't always need this the largest amount of spark duration and energy. So you have to tailor that appropriately for the application. Um, spark plug interval changes, spark plug KV at the end of the life, the demand of the spark plug over the entire engine load. Uh, it's recommended to monitor for engine misfire at all load conditions and tune the spark as necessary using the current and duration menus. High current, short duration profiles generate a lot of initial energy to ignite a poor gas mixture. So if that's what is going on with your engine, that's how you would approach that. With longer duration spark, it helps to keep a mixture lit longer into the rotation cycle. So some experimentation with, a poor mixture or poor fuel quality might yield better results one way or another. This is the spark uh, control, where you've got the Modbus register and the time, and then also the current in milliamps. And you can see in this chart that you can't go beyond, if you've got 200 milliamps selected, you can only go up to 400 microseconds. And there's a statement here. It says the device automatically limits itself for safe operation. Spark current selection with override duration. So it's going to select the spark current first, and then um, duration. If you've selected something that's off the chart, it's going to give you the current first and then limit the um, time on that to keep it within the normal current draw and not overload the circuitry. So it's programmed so that you can't screw it up and burn it up because of, putting it at too high of an output level. So that's what that chart means. The terminal display, you can see some things in orange and some things in green here. And over here, it also notes that the node ID on the RC version, um, and that's what we're talking about. This is all part of the RC terminal program. The node ID is 11, so that you don't confuse between the wrong terminal program and try to use it on an RC and so forth. So these values in green, this is the duration and the spark current, and those are values that can be written, indefinitely with unlimited amounts of writes to that without overwriting and damaging the EEPROM. Global timing, and then individual cylinder timing. These values right here, uh, default global, default individual, duration, and spark current. These are default values that will be loaded in every time you start the engine. So this is where you start out, and from there, your Modbus selections, when you write to the unit, that's when you're going to change from the defaults. And that's the conclusion of the disk triggered. We've sometimes called them event triggered. Um, Doesn't always have a disc. Sometimes the events are holes drilled in a flywheel. So there's many ways to apply these depending on the size of the engine, the cost of the installation, and various other factors. So are there any questions at this time?
That was an excellent review. Folks, any questions for Mr. Tom Smith on event-triggered, disk-triggered ignitions? Going once, going twice. Very good. Well, as I said, we wanted to make sure we gave everyone a good, a good basis on the ignition products here as new personnel come into the organization, and everybody can use a refresher now and again. Certainly, as the new ignitions come out next year for the large engine, the NGI 5000 and the NGI 3000 at the end of next year, having this good foundation is going to be critical. So we will make sure that this is on the website here.